Is it visible to you? Theoretical vapor compression cycle with dry saturated vapor after compression. Is it visible to you?
Yes, sir.
Yes, sir, visible.
Okay, all of you listen. In the previous class, we discussed about the vapor compression refrigeration cycle that you already did the experiment in the thermal engineering laboratory, performance test on refrigeration test rig. Okay. Now, now we will move on to the vapor compression cycle. Here, this is the first case. This is a pH diagram and this is a temperature entropy diagram. Okay. So, you see the point number 1. Point number 1 corresponds to evaporator inlet. Okay. Not evaporator inlet, evaporator outlet. Point number 4 corresponds to evaporator inlet. And this process is called 4-to-1 process is called evaporation process. Okay. So point number 1 is evaporator outlet. What is the condition here? Here you see that this is a saturated liquid line and this is a saturated vapor line. So point number 1 is in between saturated liquid and saturated vapor line, but it is close to saturated vapor line. Okay. So here you see that point number 1 is in wet region. Point number 1 is in wet region. Wet region means it contains liquid plus vapor. Point number 1. Therefore, it is called as wet vapor. But the point number 1 is close to vapor line. Close to vapor line because this is a liquid line. Okay, but point number 4 is close to liquid line. Point number 1 is close to vapor line. This is the dry and saturated vapor line. So at point number 1, less percentage of liquid and more percentage of vapor. For example, at point number 1, quality of the refrigerant or dryness factor of the refrigerant is equal to, example, X is equal to 0.9. Okay, that what is its meaning? At point number 1, this meaning is 90% vapor and 10% liquid. Like the wet steam. Wet steam means nothing but it contains water particles. So here also you see that refrigerant particle is there, not water particle, refrigerant particle is there here. In steam, water particle is there. Okay. So it is liquid plus vapor mixture. Therefore, it is called as wet vapor. So this is one of the condition. Here you see that the wet vapor enter the compressor. Okay, compressor inlet through the suction valve. Wet vapor. So what is the exit condition? Dry and saturated vapor, because this point number 2 is on the saturation curve. So 1 to 2 process 1 to 2 is compression. Wet vapor enters the compressor inlet and leaves as saturated vapor. But in actual case, practical case, what will happen? Dry superheated vapor enter the compressor inlet and leaves as superheated vapor. Okay, so this is one of the condition. Suppose if the wet vapor entry condition at the inlet of the compressor or at the exit of the evaporator is wet vapor, that means it contains liquid plus vapor, refrigerant vapor. Therefore, the point number 1 is in between these two lines. Point number 4 is also wet region. It contains liquid plus vapor. Okay, so when point number when a point is marked in between these two lines, that is called wet region. It contains liquid and vapor. Point number 1 is close to vapor line. Point, therefore, it contains more amount of vapor, refrigerant vapor. Point number 4 is close to liquid line. Therefore, it contains more amount of liquid. Okay, point number 2, only vapor is available, dry and saturated vapor. At point number 3, liquid is available, no vapor. Okay, so what is the condition here? Here you see that wet vapor enter the compressor. This is the evaporator outlet and leaves us dry and saturated vapor. Okay, this is one of the condition. The another condition may be the point number is assuming that shifted to vapor line. That means entry condition is exit is dry and saturated vapor. The exit of the evaporator is dry and saturated vapor, and after compression you find that it leaves a superheated vapor. Superheated vapor. This is another condition. And third condition is the entry condition itself superheated vapor and leaves a superheated vapor. So there are three conditions available. Okay, and the last class we discussed about the degree of superheat and degree of undercooling. Undercooling means we are cooling the refrigerant, liquid refrigerant below the saturated liquid line. Okay, the point number 3 is shifted leftwards. Superheating means point number 2 is shifted rightwards, superheated region. Okay, that means exit is superheated vapor. So these are the condition and theoretical vapor compression cycle exist. Okay, now we will move on to that problem that is explained here. We will move on to another topic. Here you see that what is that condition? Entry condition is this point number 1 is on the saturation curve. Okay, therefore dry and saturated. This is the evaporator outlet. Exit is superheated vapor. So what will happen here when the entry condition is wet vapor? That is very important. Analysis is what is happen because of this condition. What is happening here? So here you see that wet vapor enter. Wet vapor means we know that wet vapor leaves and entry is compressor inlet. Okay, so here you see that refrigerant effect is less. Refrigeration effect is less because the enthalpy difference is small. Enthalpy difference is small because this contain liquid also. Liquid also. Okay, assuming that the point number 1 is shifted here, what will happen? This refrigerating effect is more. The enthalpy difference is more. H1 minus H4 is larger value. Okay, assuming that point number 1 is shifted on the dry and saturated curve. Assuming that point number 1 is shifted right side of this curve, superheated vapor enter or leave the evaporator. In that case, the refrigerating effect is high. H1 minus H4 value is very larger value. In that case, refrigerating effect is more. What is COP? COP is equal to refrigerating effect divided by work input. Okay. So when this value H1 minus H4 difference is large, then COP is improved. So here we see that wet vapor leave the evaporator. In such a case, COP is found to be low because the difference is enthalpy difference is low. Okay, enthalpy difference is less value. Therefore, COP is less. So for superheated vapor condition, superheated vapor, we know that the COP is higher. COP is higher when compared to the wet vapor. So from the pH chart itself, we can easily know the enthalpy value. H1 value, you project it downward vertically, then H4 value project it downward vertically. This gives the enthalpy value in terms of kilojoule per kilogram. This difference is smaller value. When this point number 1 is shifted to, or it is marked on curve, dry and saturated vapor, then you see that the difference is larger. So the COP is improved because it contains only vapor only at evaporator exit. Okay, all the liquids are vaporized, evaporated by absorbing heat from the surrounding media. In such a case, refrigerating effect, the amount of heat absorbed is larger. Assuming that the vapor leaving the evaporator is superheated vapor. In that case, H1 minus H4. Superheated vapor means the point number is just right side of the curve, assuming that here. Okay, then the difference is larger, and automatically COP value higher because COP is directly proportional to amount of heat absorbed. Okay, so what are the methods by improving the COP? One is COP is equal to refrigerating effect divided by work input. Refrigerating effect is nothing but amount of heat extracted from the surrounding medium. So if the heat absorbed from the surrounding medium by the refrigerant is more, then automatically COP will increase. That is one point. The other thing is COP is directly proportional to 1 by work input, or it is inversely proportional to work input. So if you reduce the power consumed by the compressor motor, then you can improve the COP. These are the two ways. And also if you reduce the heat loss from the system or any refrigerant leakage, okay, or friction losses, you can reduce the, you can improve the efficiency. Okay, so these are the method by which you can improve the efficiency. We know the COP formula, you already studied in the laboratory class. Okay. Here you see that COP is equal to refrigerating effect divided by work input. Divided by, this is divided by. So COP is directly proportional to refrigerating effect. Refrigerating effect is nothing but amount of heat absorbed from the surrounding medium, example food material or water. Okay. So when heat absorption is higher, then its enthalpy will increases. So in such a case, COP will be larger. Okay. And another is it is inversely proportional to work input, power required. So when power required is reduced, if you use efficient motor, okay, then power consumption will be little bit lower. Okay, then we can improve the COP. So if you reduce the work input required to drive the compressor motor, then we can improve the COP. So this is the formula to find the COP. We know that the enthalpy difference H1 minus H4 divided by the compressor work input H2 minus H1. H2 is greater than H1 and H1 is greater than H4. And we know that the isenthalpic process, enthalpy remains constant during the throttling process. Therefore, H4 is equal to H3 or HF3. F is nothing but fluid, liquid enthalpy. Okay, that's all. Now we will see the is it visible to everyone? Hello, any one of you? Naveen? Naveen is there?
Yes, sir. Yes, sir.
I shared the property table in chat. Is it visible?
Yes, sir.
Okay, all of you listen. This is similar to steam table and steam chart. Okay, this is visible to steam table and steam chart. So only thing is the fluid is different. In that case, we know that steam is the working fluid. Okay, but here refrigerant is the working fluid. So sample example is given, chart is given, table is given. Here you see that saturated refrigerant is given 134A. This 134 is a type of refrigerant. This type of refrigerant you already studied in thermal engineering laboratory. This is temperature table. Similarly, pressure table is also there. Okay. So here you see that similar to the steam table, property values are given. A temperature is one of the property. Saturation pressure is given corresponding to the temperature. What is its saturation pressure? Kilopascal is given. Then specific volume data are given. Specific volume means with respect to unit mass. Okay, with respect to unit mass. So specific volume data are given. Specific volume data are given in terms of meter cube per kilogram. And then specific volume. What is this specific volume? This is specific volume of liquid. F stands for fluid, liquid. This V for volume. What is this G? G for vapor, gas. Specific volume of gas or vapor. And then internal energy value is also given. Internal energy is denoted by the letter U. We know that. Okay. This is specific volume of internal energy of liquid, F for fluid. Then the internal energy of gas or vapor, G for gas. What is F of G?